Hello and welcome back to the Abacus 11 Plus YouTube channel. Today, yet again, we have another real-life 11 Plus school sample maths paper. Today, the school is going to be Bancroft's school. So we're going to go through these solutions and work out the best way to answer each and every single question. As always, the link to the actual original paper will be in the description, so do make sure you try it out for yourself, ideally before you watch this video. So without any further ado, let's get into these solutions. Okay, so here for our first question, we've got, as usual, quite an easy opener. So main thing here is no silly mistakes. Make sure you take your time and you focus, because these questions we should be able to get correct. So we're filling in the missing numbers in the boxes. Something plus 488 equals 731 plus 489. So we know that when we see this kind of question, the left-hand side needs to equal the right-hand side. So here we start by working out what the right-hand side equates to. We have 731 plus 489. We can use column addition. It won't be too slow. So 1 plus 9 gives us 10, so 0, carry the 1. Then we have 3 plus 8 giving us 11, plus the 1 gives us 12. Then we have 7 plus 4, 11, plus the 1 again is 12. So we have 1220 or 1,220 on the right-hand side. And that means that the left-hand side must also equate to 1,220. But this time it's something plus 488. So all we do to work out this question mark figure is we take this 1220, right? And we subtract 488. Essentially, we have question mark plus 488 equals 1220. So we want to end up with question mark equals something. We want question mark on its own. And to do that, we subtract 488 from both sides of the equation, the left-hand side and the right-hand side. So we take our 1220, we subtract 488. 0 minus 8 we can't do, so we take a 10 from the 2. 10 minus 8, we have 2. Then 1 minus 8, again, we can't do. Take a 10 from the 2. 11 minus 8, we have 3. 1 minus 4, we can't do. Take a 10 from the 1. 11 minus 4 gives us 7. So 732. That is our missing value, 732. Let's put it in the box over there. Now, for this next part, at the bottom, we have something times 7 equals 43 times 14. So let's again start by working out this right-hand side of the equation where we have all the values. So 43 times 14. Again, we can simply work this out using our column normal simple method. So we have 3 times 4, 4 times 3, 12, 2, carry the 1, 4 times 4, 16, add the 1 is 17. Placeholder here, we don't start in this column, we start in the next column. So now we have 1 times 3, 3 times 1, which is 3, 4 times 1, which is 4. So 2 plus 0, 2, 7 plus 3, 10, 2 plus 4, 6. So 602 on the right-hand side. So something times 7 is 602. We work out that something by, if we make it a bit more clear, we work that out by dividing both sides by 7. This will leave us with question mark equals on its own, which is what we want. So 602 divided by 7. Let's do it. Well, 7 doesn't go into 6, so we do 7 into 60. Well, use our times tables. We know that 7 times 8 is 56. So it has to be 8. 7 times 9 would be too big because 7 times 9 is 63. That's why it's so important to be sharp with our times tables. So 8. 7 times 8 is 56. carry the 4. 7 into 42 is going to be 6. 6 times 7 is 42. So we have 8 and 6 giving us 86, and our answer is 86. 86 times 7 is 602. Okay, so here we have an interesting question. We're told that 1,000 divided by 8 is 125. So what's 1,000 divided by 16? And we have to give our answer as a decimal. So let's think about what's going on here. What do we really mean by division? If we have 1,000 divided by 8, what does this actually mean? Well, it means that we're taking 1,000, and let's use a different color to really make this clear. We're taking 1,000 and we're dividing it into 8 equal pieces. That's what division is. Dividing something into a number of equal pieces. The best way to think about it is like a pizza. Everyone loves pizza, right? So we have a pizza. And if we divide that pizza into 2 or into 3, we're dividing that pizza, if we're fair, into 2 or 3 equal pieces, equal sections. So back to our question, if we know 1,000 divided by 8 is 125, that means when we take 1,000 and we divide it into 8 equal sections, each section will be equal to 125. So now if we have 1,000 divided by 16, we're taking that same 1,000, but instead of dividing it or cutting it up, cutting that pizza into 8 sections, we're cutting that pizza into 16 sections, twice as many sections. So if we're cutting the pizza into more sections, is the result going to be smaller or bigger? It's going to be smaller because we're cutting up into more. There are more mouths to feed. So using that logic and understanding, if 1,000 divided by 8 is 125, then 1,000 divided by 16 should be half of 125. So we take 125, we divide it by 2, we have 6, and then we have 2.5. So 62.5. It makes sense, right? If we have a pizza and we cut it into more sections, then each person, each mouth there is to feed gets less pizza. So 62.5 is our answer. That's how we think about this. And then same thing for 1,000 divided by 32. Now, if we have that same pizza, I mean, you're not going to get much food anymore because we're cutting up into, again, twice as many sections, twice as many pizzas or pieces. So if 1,000 divided by 16 gives us 62.5, then 1,000 divided by 32 will be half of 62.5. So 62.5 again divided by 2. Well, 2 into 6 is 3. 2 into 2 is 1. And then 2 into 0.5 is 0.25 or 0.25. So our answer is going to be 31.25. That's all we have to do to work this out. We don't have to start trying to work out 1,000 divided by 16 from the very start. We don't do this. We take what they've given us in the question and we apply our understanding of what division actually means. And it gives us these answers. Okay, so for this next question, how many seconds are there from 11:45 a.m. until 12:10 p.m. on the same day? So first, let's work out the number of minutes between these two times. And then once we know the minutes, we simply convert it into seconds. So this question shouldn't be too hard, but we have to make sure we're careful and we don't make any silly mistakes. So to go from 11:45 to 12:10, the smartest way is to always break it up into pieces. Don't rush. So you have 11:45, then go to 12 noon, and then go from 12 noon to 12:10. So 11:45 to 12 noon, that's going to be 15 minutes. And then 12 to 12:10 is, of course, going to be 10 minutes. So overall, we have 25 minutes. Now let's use some understanding of conversion and a bit of ratios, actually. So we have minutes and we have seconds. We know that 1 minute is 60 seconds. So if we have 25 minutes, how many seconds is that going to be? Because of course we need to know the seconds, not minutes. Well, we simply use our understanding of ratios, that ratios must remain consistent. So if here to here, we're multiplying by 25, then to go from 60 to our mystery number, we're also going to multiply by 25. So the number of seconds is going to be 60 multiplied by 25. So 60 times 25, we can actually do this in our heads using mental maths. At first, we can do 6 times 25, and then whatever answer we get, we add a 0 to it. So what's 6 times 25? Well, we know 2 times 25 is 50. But then 6 times 25 is simply 3 lots of 2 times 25. So 50, 50, 50, which of course is going to be 150, 50, 100, 150. So if 6 times 25 is 150, then 60 times 25 is 150, add another 0. So 1,500 seconds. Okay, so for this question, we're told 25% of a number is 2.6. What is that number? So here, let's just use our basic understanding of percentages and just use a bit of ratio knowledge. So 25% is 2.6. So here we have percentage, and then we have number. Well, if 25% is 2.6, then we want to work out the full number, which is going to be 100%. Then we can think about it like this. Again, using our ratio understanding, to go from 25% to 100%, the full number, we multiply it by 4. So to go from 2.6 to the full number, we again are going to multiply by 4. So we have 2.6 times 4. Well, 2.6 is 2 and 0.6, so we can do mental maths here. 2 times 4 is 8. 0.6 times 4 is 2.4. So 8 plus 2.4 is going to give us 10.4. So 10.4 is our number. Now for part B, we have 1.5 here, 3 here, and we have to work out what's going to go here. So let's just see how many bounces or gaps there are. So to get from 1.5 to 3, there are 1, 2, 3, 4, 5 gaps. And if the difference between 1.5 and 3 is 1.5, right, 3 minus 1.5, then that means if there are 1, 2, 3, 4, 5 gaps, each gap must be worth 0.3. 1.5 divided by 5. Right? And in that case, all we have to do is start at 1.5, add 0.3, and add 0.3 again. So the first bounce gives us 1.8. Second bounce gives us 2.1. And we can confirm this is correct because if we continue the bounces, we have 2.4, 2.7, and then of course 3. So our answer is 2.1. Okay, now here for part C, we have a very interesting question. And it's going to require some algebra. Because here we're told the sum of two numbers is 35 and their difference is 7. What are those two numbers? So we have to decode this text and we have to turn it into maths. So the first thing to turn into maths is this first part of the question. The sum of two numbers is 35. So let's say we have two numbers. Let's call them X and Y. Now, don't be afraid of the letters. It's just, we could use anything. We could say apples and bananas. We could say A and B. We could say anything. X and Y just represent normal numbers. It could be any numbers. It could be 10, it could be 5, it could be 2, it could be whatever. Just that for this question, we're going to call it X and Y. It helps us. So X plus Y, these two numbers we're talking about, equal 35. And then their difference is 7. How do we turn that into maths? Well, if their difference is 7, that means that the bigger number minus the smaller number should give us 7, right? Like when we say that the difference between 3 and 10 is 7, that's because 10, the bigger number, minus 3, the smaller number, equals 7. So let's say that X is the bigger number, okay? So let's say this one is the bigger number. What that means is that X, the bigger number, minus Y equals 7. Okay. Now we have to rearrange this equation. And all that means is we want to take out one of these variables. So we have X and Y. If we can get an equation all in terms of X, it will allow us to work out what X is, right? Let's take this equation here. If this equation only has X's and then numbers, we can rearrange that. We can muddle that up and we can end up with X on one side and a number on the other side. And that's always what we want to end up with. So we're going to start here at the bottom. We're going to rearrange this equation. And for this particular equation, it's actually easier to rearrange and get X equals something. Because all we have to do that is add Y to both sides. We have our left-hand side and our right-hand side. If we add Y to our left-hand side, these two cancel out. And if we add Y to our right-hand side, we get 7 plus Y. Now we take this definition of X. We now know what X is. We take this definition of X and we plug it into X over here. So let's clean up this area. So we know X is 7 plus Y. So that means that instead of writing X plus Y equals 35, we can say that 7 plus Y, remember that's what X equals to, we just worked it out, 7 plus Y equals 35. And now we're in familiar territory. We can clean this up because Y plus Y is 2Y. Same way apple plus apple is 2 apples. Banana plus banana is 2 banana. Y plus Y is 2Y. So we have 2Y plus 7 equals 35. We can minus 7 from both sides because now we want to end up with Y equals. So Y on one side, number on the other side. So we can minus 7 from both sides. This gives us 2Y equals 35 minus 7, which is 28. Then we can divide both sides by 2. And this should leave us with 2Y divided by 2, which is simply Y. And then 28 divided by 2, which is 14. So Y is 14. Awesome. So Y equals 14. But now we can work out what X is because X plus Y equals 35. And if Y is 14, that means X plus 14 is 35. So we can minus 14 from both sides of the equation. And we have X equals 35 minus 14, which is going to be, well, 35 minus 10 is 25. 25 minus the extra 4 is 21. So X equals 21. And there we have it. The two numbers are 21, we'll put it in black, and 14. Using algebra, rearranging the equation, and using substitution. So you see, it's not that scary. Algebra, rearranging linear equations, substitution. We've just done it all right now. That's all it is. And here are our answers, 21 and 14. Okay, here we have a very fun question. Each number in a sequence is calculated by multiplying the previous number by 3 and then subtracting 7. If the first number is 4, what's the fourth number? So we have position 1 or number 1. Then we have position 2, 3, and 4. We want to work out position 4, number 4, but we're starting at number 1. So we're told the first number is 4. So to get the second number, the next number in the sequence, what do? We've been told already. We multiply by 3 and then subtract 7. So we can do it. I mean, there's not many numbers to get to 4. So here we can just simply work it out ourselves manually, step by step. So multiply 3 by 4 gives us 12. Subtract 7 gives us 5. Right? So 4 times 3, 12. 12 minus 7, 5. 5 times 3, 15. 15 minus 7, 8. 8 times 3, or 8, 16, 24. 24 minus 7, 17. So our fourth number is 17. So now for part B, we're told if the third number is 20, what is the second number? So let's just simply take this same position structure. We have 1, 2, 3, 4. Here we're told the value of the third number is 20. Remember, to go from 2 to 3, what did we do? We multiplied by 3 and then we subtracted 7. So now to go from 3 back to 2, we have to do the inverse. We have to turn it around, do the opposite. So this time we're going to start by adding 7, giving us 27. So we do 20, add the 7, giving us 27. And then we're going to divide by 3, the opposite of multiplication, giving us 9. So this should be 9. And we can check it because we know that 9 times 3 gives us 27. 27 minus 7 gives us 20. So 9 indeed should be our second number. Now, this is the way we can work this out. Of course, this solution would have been very different if instead of being told to work out the fourth number, we were told to maybe work out the 40th number or 60th number. Then we would have to use the nth term and some more complex formulas. But for this, we're fine. 17 and 9. Okay, so here for this question, we've got something a tiny bit more complex. So let's go through the solution. How do we work this out? Well, if you've read the question, let's try and think about this visually. It always helps. So we have a drinks bottle. Here's our really badly drawn drinks bottle. Maybe it's a carton of juice, whatever. And then we're told this drinks bottle, which is actually a fizzy drink, not a carton of juice, is a third full. So about here, right? It's a third full. Then we're told that this person who is clearly thirsty drinks 40 milliliters. So let's say that's 40 milliliters of this fizzy drink. And now the bottle, the same bottle, is a quarter full. And of course, a quarter full is less than a third full. So how much fizzy drink does the bottle hold when it's full, 100% full? How can we work this out? Well, we have it visually here. This visual aid should help us. But what's really going on maths-wise? Well, we're starting at a third full. We drink 40 milliliters, and then drinking that 40 milliliters brings us down to a quarter full. So what we really need to work out is the difference between a quarter and a third. If we can work out this difference, we know that this difference is equal to 40 milliliters. And then we can use that understanding to work out what the full bottle must hold. So let's go through it step by step. But that's generally what we're going to do. We start by working out what this difference is. Can we actually work out the difference in terms of a fraction between a third over here and a quarter over here? What is that number in fraction form? Well, to do that, we need to know how to subtract fractions. So we have a third minus a quarter. So here it's all about the common denominator. It's all about that. And we do that by multiplying both the numerator and denominator of a third by 4. So 3 times 4, 1 times 4, both numerator and denominator. And then also, to get this common denominator of 12, we take a quarter and we multiply both the numerator and the denominator by 3. So for the left-hand side, we have 1 times 4, which is 4. 3 times 4, which is 12, our common denominator, same number. That's all common means, same. And then we have 1 times 3, which is 3. And then, of course, we have 12, 4 times 3. So now it's pretty simple. We have 4 over 12 minus 3 over 12, which should give us 1 over 12. We simply subtract across the numerators, but the denominator always stays the same. So 1 over 12. So that means we now know that if we have the bottle and we have milliliters, we're going back to ratios. This ratios understanding really is important in speeding up working for our 11 plus exams. So we have bottle and milliliters. We can draw a relationship between those two things based off what we know. We know that bottle-wise, 1/12 of a bottle is equal to 40 milliliters, right? Because that's the difference, 1/12, which we also know is 40. But then to work out the full bottle, we want 12 twelfths, right? In fraction world, 12 twelfths will equal 1, which is the full bottle. So how many milliliters will this be? Well, we simply use ratios. 1/12 to 12 twelfths, we multiply by 12. So 40 to our mystery number, we multiply by 12. Consistency. 40 times 12, or 4 times 12 is 48. So 40 times 12 is 480. So that's our answer. The full bottle holds 480 milliliters. Okay, so here for this question, we're told that traveling by train from Edinburgh to London, we pass a sign saying London 151 miles. So 151 miles away. After 7 more miles, we pass another sign saying Edinburgh 242 miles. So how far is it by train from Edinburgh to London? So let's make this visual. This question is begging us to make it visual. We have Edinburgh and we have London, LDN. Okay, Edinburgh and London. So we start at Edinburgh. We're traveling by train, okay? And then we get to a point where it says London 151 miles away. So this is the first sign, first S. We know that at the first S, we are 151 miles from London. But then we travel 7 more miles. Let's say it's this. Not to scale, by the way, but we travel a bit more distance. And then we get to sign 2. Second S, or second sign. Let's make it full. Second sign. This sign, which is 7 miles, we see that Edinburgh is 242 miles away. So let's use black. From this second sign to Edinburgh is 242 miles away. So now how far is it to go from Edinburgh all the way to London? Well, think about it. It's going to be the 242 add the 151 minus the overlap. So we have 242 plus the 151 minus the overlap, this overlap here of 7 miles. So we can work this out. 242 plus 151. Well, this gives us 393, so 393. Then we take away 7, and this gives us 386. So it's 386 miles to get from Edinburgh to London by train. And that is our answer. Okay, so here for this question, we're told there are 50 houses on the north side of the road, and their numbers go up in twos from 1 to 99. But then we're told that houses 17 to 41 are unfortunately demolished. So if that happens, how many houses are left standing on this north side of the road? So we start at the fact that we know there are 50 houses, okay? And really, all we have to do to work out how many houses are left standing is simply, we have to take the 50 and minus the number of houses that are demolished. And if we take 50 and minus the demolished houses, we should be left with the houses left standing. Left stand. Okay. So how many houses were demolished? This part of the equation. Well, we're told it's houses 17 to 41. But how many houses does that actually represent? Well, it goes back to the question. We know that the numbers of these houses go up in twos from 1 to 99. So we have number 1, we have number 3, we have house number 5, house number 7, house number 9, 11, 13, 15, 17. It goes up like that. So here, if we have 17 to 41, then that means the houses that are actually demolished are going to be house number 17, house number 19, house number 21, 23. So we need to understand how this is actually working. So to work out how many houses are demolished, we can think about this very practically. Let's go back to the very start. We have 0 to 10. Between the numbers 0 and 10, how many houses are there if we're counting up and going up in twos? We have house number, put it in black. We have house number 1, 3, 5, 7, 9. Between 10 and 20, same thing. We have house number 11, 13, 15, 17, 19. So between a gap of 10, so 0, 10, 10, 20, 20, 30, we should have 5 houses. 5 houses. So now we're trying to work out the number of houses between 17 and 41 because that will tell us how many houses are demolished. Well, if we think about it, 17 and 41. Well, going from the 10 to 20 bracket, we're going to have house number 17 and house number 19 demolished. And then going from the 20 to 30 bracket, we're going to have 5 houses demolished. Like we worked out, there's 5 houses every 10. Then between the 30 and 40 bracket, we're going to have again 5 houses demolished. And then of course, in the 40 to 50 bracket, we have house number 41 demolished. So altogether, let's put it in a different color. Let's say green. We have 2 houses demolished here in this bracket, 5 houses here, 5 houses here, and then 1 house here. So altogether, the number of houses demolished is going to be 2 plus 5, 7, plus 5, 12, plus 1, 13. So 13 houses demolished. But overall, we have 50 minus 13 giving us, well, 50 minus 10 is 40. 40 minus 3 is 37. So yes, overall, our answer should be 37 houses are left standing on the north side of this road. Okay, so here for this next set of questions, we can see that we have to be comfortable with percentages. So here for part A, what is 60% of 45 plus 40% of 45? Well, here, we just have to zoom out and use our brain and see what's going on here. If we have a bottle and we're told to work out what 40% of that bottle plus 60% of that bottle equates to, well, it's just going to be the full bottle, because 40% and 60% makes 100%. So here, without doing a single line of working, if you zoom out and you see what's going on, we should know the answer here is 45. So here for part B, we have 40% of 52, take away 52% of 40. So we can start with this first one, 40% of 52. And here, we can use our understanding that every single percentage is really a fraction in disguise, because 40% is simply 40% of 100%, which cancels down to, well, from 40 over 100 cancels down to 2 over 5, using our common factor of 20, right? Because 20 goes into 40 2 times, and 20 goes into 100 5 times. So 2 over 5. So we have 2/5 of 52. And remember, in maths, when it comes to percentages, of is simply a code word. It simply means multiplication. So we have 2 over 5 times 52 over 1. Well, how do we do this? First, let's start by multiplying the two numerators, giving us 104, divided by the two denominators, 5. So we have 104 divided by 5. Well, 5 goes into 100 20 times, giving us a remainder of 4. 5 does not go into 4, so we add a decimal point and we add a 0. 5 does go into 48 times. So that means that overall 104 divided by 5 is 20.8. Okay. Let's clear up this space, because now we're going to move on to 52% of 40, and we can work this out a bit differently. We could do the whole thing of converting 52% into 52 over 100, but we can also do it a slightly quicker way, another way, because of this actual number. This number lends itself to a quicker way of working it out, a quicker solution. Here we can use standard percentages. And what are standard percentages? Well, we know pretty quickly what 50% of any number is, right? It's pretty simple. Just divide it by 2, just half it. So 50% of 40 is 20, just half of 40. We also know pretty quickly what 1% of any number is. Simply divide it by 100. So 40 divided by 100 is 0.4. So that means we know what 2% is. Just double 1%, 0.8. So 52% is simply going to be 50% plus 2%, which equals 20.8. So now we have 40% of 52 take away 52% of 40, which actually ends up being 20.8 minus 20.8, which equals 0. Now, you may have noticed the interesting fact that 40% of 52 is the same thing as 52% of 40. But if you go through the fractions and you turn it all into maths, it should make sense pretty soon why that is always the case. But for now, let's move on to C. So for C, we have 72% of 87 plus 87% of 28. So for this first one, let's again use standard percentages. This time I'm going to start with 10%, which is 8.7, and then 1%, which is 0.87. So to get 72%, we multiply this by 7 and we multiply this by 2. So 8.7 times 7, mental maths, 8 times 7 is 56. 0.7 times 7 is 4.9. So 56, 4.9, 60.9. Then we have 1% times 2, so 0.87 multiplied by 2. Now, just to make sure we don't make any silly mistakes, let's just do it manually. 14, carry the 1, 16, add the 1, 17. So it's going to be 1.74. So now 72%, add those two things together because this is 70%. This is 2%. So we add it together, 4, 9 plus 7 is 16, or the 1, 2, and then 6. So we have firstly here 62.64. And in actual fact, let's do the same thing for 87%. Start at standard percentages. 80, we make it from 10%, and 7, we make it from 1%. 10% of 28 is 2.8. 1% is 0.28. Multiply this by 8 to get 80%. Multiply this by 7 to get 7%. So 2.8 times 8, well, 2 times 8 is 16. 0.8 times 8 is 6.4. So we have 16 plus 6.4, which is 22.4. And then we have 0.28 times 7. Let's do it manually. 7 times 8, 56. 2 times 7, 14, plus the 5, 19. So 1.96. Add it all together. Let's align this a bit better. So we have 1.96. Add these, we have 6, 13, carry the 1, 3, 4, 2, 24.36. So now we have 62.64. 24.36. Add these together. You have 0 and 1. We have, again, 10, carry the 1. 3, we have 7. And then we have 8. 87.00, or just 87. That is our answer. Okay, so here for this question, we're told that 1234 is divided by 23, and the remainder is 9. So part A, what is the remainder when 1233 is divided by 23? So here we need to understand the concept of remainders and what remainders actually mean. And it's from that understanding that we can confidently answer this question. So let's say we have 50, okay? And we have 104. What is the remainder here? Well, the way this works is we try and divide 104 by 50. We realize that 50 goes into 100, or goes into this number fully twice. So it goes in fully twice, but then we have 4 left over because this 104 number, this number that we're dividing, is actually 4 bigger than the number that 50 goes into wholly. So in other words, if we're told the remainder is 4, that means if we were to take that 4 away from 104, that's a 4, then we're left with a number that 50 goes into wholly with no remainders. That's how remainders work. So we can apply that understanding to this question. If 1, 2, 3, 4, 1, 2, 3, 4. So let's actually write this out properly. So 1, 2, 3, 4, 1, 2, 3, 4. The commas go here. So it's 12,341,234. When divided by 23, the remainder is 9. Which means if we take 9 away from this number, we're left with a number that can be divided wholly by 23. And that number is going to be, well, take away 9 from this, just take away 9 from this last bit at the end. Well, 34 minus 9 is going to give us 25. This tells us that 23 wholly goes into the number 12,341,225. Okay. So now, on a side note, let's work out part A, because with that understanding, we should be able to work out everything, but let's just go through part A. What's the remainder when we divide 1, 2, 3, 4, 1, 2, 3, 3 by 23? Well, here, because 1, 2, 3, 4, 1, 2, 3, 3 is 8 more than 1, 2, 3, 4, 1, 2, 2, 5, it's 8 more, the remainder is going to be 8. And now for part B, we can use that same understanding to work this out. Remember, the number that we're comfortable with that can be wholly divided by 23 is 1, 2, 3, 4, 1, 2, 2, 5. So what's the remainder when we divide 1, 2, 3, 4, 1, 2, 5, 0 by 23? So now this is 25 more. Okay, so 1, 2, 3, 4, 1, 2, 5, 0, 25 more than our safe number. So in this case, if it's 25 more, then we're going to get one more whole 23 in there. We're going to get one more whole 23 because 25 is 23 plus 2. So if we divide it, we're going to get one more whole 23, but then we're going to be left with 2. So the remainder is going to be that 2 we're left over with. So the answer is 2. And finally, for part C, we have to work out the remainder when 2468 is divided by 23. Now, the first thing we have to notice is that 2468, apart from being a mouthful to say, is actually a multiple of 1, 2, 3, 4, 1, 2, 3, 4. It's 1, 2, 3, 4, 1, 2, 3, 4 multiplied by 2. Or in other words, it's 12,341,234. Let's make that cleaner. 234 multiplied by 2. So let's think about this. We know that for 1, 2, 3, 4, 1, 2, 3, 4 divided by 23, the remainder was 9. We're told that in the question. But what happens to the remainder when we divide a number twice as big? Well, if we divide a number twice as big by the same divisor of 23, our remainder should double. It should go from 9 to 18. I mean, think about it. If we go back to our example with 104 and 50, 50 into 104, the remainder was 4, remember? So 2, remainder 4. But if we turn that 104 into 208, and we have the same divisor of 50, then 50 goes into 200 4 times, but then this time the remainder is going to be 8. The remainder doubles. So same thing here. If the remainder, when we divided by 23, was 9, now that the number we're dividing has doubled, that remainder should also double to 18. So 18 is our answer. Okay, so here for our final question, we have a very interesting problem-solving type question. Jemima has written down 4 whole numbers. If she chooses 3 of her numbers at a time and adds up each triple, she obtains totals of 130, 143, 157, and 170. What is the largest of Jemima's numbers? So to even start to work this out, we have to use algebra. We have to ascribe some letters to these possible numbers. So let's use simple A, B, C, and D. Let's say these are the 4 whole numbers that Jemima has written down. And the reason, again, this use of algebra is so useful or so important is because these letters can hold any value. They can be anything. So it helps us just to work out what's going on. The next step when working out this question is we need to understand the different combinations that Jemima can make when she's making these triples, right? We're told that she's choosing 3 of these 4 numbers, only 3 of them. And when she chooses 3 of these 4, she adds them up and she gets 4 different totals. So that kind of gives us a clue that there are really 4 different combinations of these numbers that we have to find in terms of triples. So of course, the easiest triple to find, the first one should be just A plus B plus C. Second one, A plus C plus D. Third one, if we start with B, we can do B plus C plus D. And the fourth one we can do is let's do B plus A plus D. There are no more combinations we can make that haven't already been made. So these are the 4 combinations. These are the 4 triples that Jemima has written down, all in algebra letter format. Now let's ascribe these totals to these triples, step by step. So let's say A plus B plus C equals 130. Let's say this next one is 143. Next one is 157. Next one is 170. Okay. Now, what can we do? We're trying to work out the largest of Jemima's numbers. Well, what we can do here is, if we look at these equations very closely, we can see that there are some shared elements between some of the equations. What do I mean by that? So let's take 1 and 2, for example. A plus B plus C equals 130, but A plus C plus D equals 143. Both 1 and 2 have A, put it in red. They both have A and they both have C, which means by looking at these 2 equations, 1 and 2, we can learn something learn something about the relationship between B and D. In this case, we know that if 143 is 13 bigger than 130, that 13 bigger, that difference is because of how much bigger D is compared to B. So essentially what we're saying here is that we know from these first 2 equations that D minus B, the difference, is equal to 13. And that's very useful information. So let's go through each of these equations and let's see what happens when we look at them like this. And let's be very methodical. So if we're being methodical, let's start by matching A and B. So A and B, let's match it. And let's put it A and B. If we match A and B, where can we do that? Well, we have one A and B here. We have another one here at the bottom. So A and B here. This tells us that D minus C equals 40. The difference is 40. 170 minus 130. That's from matching A and B. Okay, great. So let's take this off now. And now let's match A and C. Well, we just did that, right? A and C. First two, we can do that. If we match A and C, we know that D minus B equals 13. Now let's try and match something else. Let's match A and D. A and D. If we match that, well, how can we match that? Well, we have equation 2 and equation 4. If we match A and D, what does that tell us? That tells us that B is bigger than C, and it's bigger than C by 27. So we can now see how this is going. Let's continue. So let's now try and match B and C. If we match B and C 1 and 3, we should now be a bit quicker. Equations 1 and 3, D minus A equals 27. Okay. So now, before we move on, we should notice something. Every single time we've compared D with another number, whether it be C or B or A, no matter what we compare D to, D is always the bigger number because D minus something is always positive, which means that thing we're minusing must be less than D. So already that should give us a hint that D is the main letter we care about. It's the main number we care about. Because remember, the whole question is working out the largest of Jemima's numbers. So D is the main letter we care about. We'll keep that in mind. But let's continue. We've done B and C. Let's do B and D. Well, here we can use the bottom two, 3 and 4. We know A minus C equals 20 or equals 13 rather. And then we can do C and D. C and D, well, 2 and 3. B minus A equals 14. Awesome. That should be everything. Okay, so now we've gone through a significant step by realizing that we can analyze the differences between these letters. Now, all we have to do is use some substitution to hopefully work out what D is. Because remember, once again, D is the letter we care about. D is clearly going to be the biggest number, the largest of Jemima's numbers, because again, when we compare it to every single other letter and we subtract every single other letter from D, we're left with a positive number, which shows D must be bigger. So let's just start with equation 1. We have A plus B plus C equals 130. Let's substitute out A using this equation here. B minus A equals 14. Well, if we know B minus A is 14, we also know that A equals B minus 14. We bring the A to the right side by adding A to both sides, and we bring the 14 to the left side by subtracting 14 from both sides. And then we can use this to turn this into not A plus B plus C, but B minus 14 plus B plus C. And then we can also change out C, because we know that C equals B minus 27 right here. Add the C minus 27. We should be getting more fluid at this by now. So now we have b minus 14 plus b, and not c, but b minus 27. Okay, so let's write this all out as 1. We have b minus 14 plus b minus 27 equals 130. Let's get all the b's to one side, all the numbers to the other side. So on the left-hand side, we should have 1, 2, 3b. On the right-hand side, we should have 130 plus 14 plus 27. 130 plus 14 is 144, plus 27, well, plus the 7 is 151, plus the 20 is 171. So it's 171. And therefore, b, we simply divide both sides by 3. b equals 171 divided by 3. Now, 3 into 17 is 5, carry the 2. 3 into 21 is 7, so b equals 57. And now we should be able to work out our magic number d, because if b is 57, first of all, we can rearrange this equation because d equals 13 plus b, right? We add b to both sides. And then if b is 57, that's 13 plus 57, which is 70. 10 plus 50 is 60. 3 plus 7 is 10. 60, 10, 70. So D is 70. So it was a long-winded question, and this certainly is more of a scholarship level question, or in grammar school terms, a higher level question to really see the top of the top students. But as we've seen through this working, if you know what you're doing, if you're comfortable with algebra and you're persistent and you really push through, you can still get to the answer of D being 70, or the largest number being 70. That's our answer. Okay, so that is all for today. Make sure you like the video, subscribe, and turn on notifications so that you're the first to know when the next video is released. And on that note, I will see you all next time.